Very good evening to Dr. Liu. My name is Shahirah Binti Sabana and I'm going to present question number 3. Moving on. So this is the question that I got. The research question made by the undergraduate student is, will eating more food makes the student heavier? But then the data that was given is uh, the gender, which is the UMS female students, the student identity, the weight, the body weight of the UMS female students, and their age. So based on the data that it is quite different from the research question, so I altered the research question and made a new one that fits the variables in the data. So the research question, is there any significant relationship between the body weight in kilogram and age of UMS female students? The experimental design, the response variables in this experiment is the body weight in kilogram and the age of UMS female students. The experimental unit is the UMS female students itself. The replicates and the samplings are the same, which involves 10 UMS female students. So as you can see from the question before, the data is unorganized. So I organized the data into a table that have 3 columns. So the first column is the student ID, the second column is the body weight in kilogram, and then the third column is the age. And then I plot a scatter plot for the data. The title is the relationship between body weight in kilogram and the age of the UMS female students. So as you can see, the relationship between the two variables are linear. And then how I plot the scatter plot in R. So the first thing I have to do is setting the work directory. This is the command, and then this is the file address where I store the data that I got. I organized in a table in Excel, and then I just save it as CSV, and then I stored it in this particular file, and then I just copy the file address. So, and then I moving on to log in the data. So I give the object name, which is the weight and age, the two variables that are involved in the experiment, and then the command to read the CSV, and this is the name of the CSV, and don't forget to include the .csv so that the R can run. And then the data will be here. As you click it, it will be the same as the one in Excel. It's the same. Make sure it is the same. And then I continue to check the data frame. This is the command to check the data frame. Just type str and then the new object name, and this is the data frame. And then this is the command to make the scatter plot. So you just have to type plot and then open bracket, the name, $sign, and the weight according to the name and the $sign and the age of the student. And then I type a new title. So you can just type main equal to the title. Don't forget to add this sign. And then I also name a new axis for the y-axis and the x-axis. And if I click run, this scatter plot will be constructed by R, and then you can just save it as image here, and then just choose the width and height that you want to go. And then after I make a scatter plot, it's time to perform the assumption test. So there are two assumption tests. First one is the normality test. Normality test both of the tests can be only done in R. So if you go to R, this is command to make the normality test, which is Shapiro.test, open bracket, the object name, and then $sign, and then the first variable. So as both variables are continuous, can just name it as first variable and the second variable. So just make a normality test for the first variable, and then the same command for the second variable, but change the variable at the end. And then this is the result for the Shapiro test. For the first variable, the p-value is larger than 0.05. And then for the second variable, which is age, the p-value also larger than 0.05. Therefore, the data is normally distributed. And then for the test for homogeneity of variance, I cannot perform the Leuven test in R because both data are continuous. Both variables, which is the body weight in kilogram and the age, continuous. It is numerical, so I cannot perform the Leuven test. And then moving on to the statistical test. So I chose the Pearson correlation test because the data is normally distributed based on the normality test that we have done before. The test for homogeneity of variance cannot be performed as both variables are continuous data, and both variables also have a linear relationship. Hence, it fits all the assumption for Pearson correlation test because we know that Pearson correlation test assumptions is the normality, linearity, and both data are continuous. Moving on to the statistical hypothesis. So the H null for these experiments, there is no significant relationship between the body weight in kilogram and age of EMS female students. While the alternative hypothesis, there is a significant relationship between body weight in kilogram and age of EMS female students. And then we set the criteria, which is alpha 0.05. Then we can proceed to perform the statistical test, which is the Pearson. So in R, you can make the command for Pearson correlation test. Just type the core.test, open bracket, the object name, and then the second variable, which is the age that represents X, and then comma, the object name, $sign, and then the weight in kilogram that represents Y variable, then comma, and then just type method equal to Pearson, and then just click run. You can get the answer here. So this is the result, and as you can see, the p-value, which is 0.09927, is larger than 0.05, which is the critical value. So as you can see here, the p-value is larger than 0.05. So the result, as the p-value is larger than the critical value, the null hypothesis is accepted. So the null hypothesis stated that there is no significant relationship between the body weight in kilogram and the age of UMS female students. So to conclude, the Pearson correlation test was performed to determine the relationship between body weight in kilogram and age of UMS female students. The result that we got from the R showed that there is no significant relationship between body weight and the age of UMS female student, as the p-value is larger than the critical value, which is 0.05. And that's all. Thank you.